Hello, my name is Muhammad Al Sayed, and my ID number is 1089216. Today I'll be talking about our lab. This lab is divided into two major sections. Part 1 focuses on manually configuring static routes and default routes between two routers, while Part 2 implements dynamic routing using RIP version 2. Throughout the demonstration, I follow the confirmed addressing scheme exactly as provided in the lab. I will begin with Part 1, which uses the two router topology consisting of R1, R3, PCA, and PCC, and two loopback interfaces on R3. Let's start by part 1, configuring IPv4 static and default routes. The first steps of part 1 involve setting up the cables exactly as shown in the topology and performing the basic configuration in both R1 and R3. I begin by assigning host names, disabling DNS lookup to avoid delays, and securing the routers with the required passwords, class for the enable passcode, and Cisco for both console and VTY lines. After this, I proceed to confirm all the necessary interface IP address in both routers. A critical detail in the step is the R3 serial 000 interface IP as the DCE side of the link, so I use the clock rate 128,000 command to activate the connection. After completing the interface configuration, I verified local connectivity. Both PCs were able to successfully ping their default gateway, which confirmed correct LAN configuration. I also tested the serial link between R1 and R3 by pinging the opposite router serial interface, and the ping succeeded, showing the physical and the data layers were working correctly. However, at this stage, the remote configuration between the network failed. For example, PCA could not ping with PCC, and neither router could reach the loopback network on R3. This is normal before routing is confirmed because each router is only knows the network directly connected to itself. Using the show and the IP router command, I confirmed that the router table were missing in the necessary entries R1 only listed and then 192.168.0.0 LAN and the 10110 but had no entries for the 192.168.1.0 network or either of the loopback networks on R3. Similarly, R3 did not yet have routes to the R1 192.168.0.0 network. Let's move to task 3. Configure static routes. To enable connectivity between the networks, I began configuring static routes on. I added a recursive static route on R1 for the 192.168.1.0 network, as shown here. This route uses the next hop address of the R3 serial interface 10112. The command was IP route 196.168.1.0, 10112. This allows R1 to forward packets toward R3 whenever the destination is the R3 LAN. Although full communication still wasn't possible yet, but R3 had no return route. And step 2, I confirmed a directly connected static route on R3 to provide this return path instead of uh, specifying a next hop IP. I specified the exit interface S011, creating a directly connected static route. The command we used was IP route 192.168.0.0.255.255.255.0 S011. Because directly connected routes require only one lookup, they are slightly more efficient than recursive routes. After adding the route, PCA and PCC were able to successfully communicate. Let's move to step 3. In step 3, I configured routes for the R3 loopbacks network from R1. I used the recursive method for the 198.133.2.190 network and the directly connected method for the 209.165.200.224 network. This demonstrated both static routing styles again and ensured that R1 could reach all the R3 internal network. As step 4, I required removing these static routes using the no IP route commands. This cleared the routing table and prepared R1 for the next task, adding a default route. Let's move to task 4. And the final task of the part 1 is task 4. I configured a default static route, also known as the quad 0 route on R1. This route sends all the unknown traffic out of the serial 010 interface. The command used was IP route 4040 S010, Using show IP route, I confirmed that the route appeared with an S code, meaning it is the candidate default route. After applying the default route, I repeated the connect. I repeated the route. I repeated the connectivity tests. PCA was able to successfully ping R3 loopback address, confirming that all the non-specific traffic was now being properly forwarded using the gateway of the last resort. With all these tasks, they were all for the part one. Now it's completed. Let's move to part two. This was my friends, but I have a good brief about it, so I'm going to start talking about it. The main goal here was to implement the dynamic routing protocol RIPv2 across the three router topology involving R1 and R2 and R3. This part introduces multi-router routing updates, subnet mask propagation, and the redistribution of a default route. Let's talk about task one. Okay. Task one, let's begin. As before, I begin by performing the initial setup and verifying the basic connectivity of all the routers and PC, despite the LAN functionally correctly end-to-end ping between PCs failed at this stage, which confirmed that dynamic routing was required. Here, in step one, I configured RIV v2 on all routers, so both R1 and R3. I entered the router rep set version 2 and used the passive interface G01 command to stop rep updates from being broadcast onto the LAN. I advertised the 172.30.00 network along with the 100.00 serial network. On R2, I advised all connected network except the 209.165.2010 network, exactly as required in the lab instructions, as shown here. Let's move to step 2. After enabling RIPv2, we still saw that the PCA could not ping with the PCP. This occurred because RIPv2 confirms automatic summarization by default. When routing updates cross the boundaries at R2, the 172.30.10.0 and 172.30.300 subnets were summarized into the classifier network 172.30.00.16, leading to missing subnet information in R1 and R3, as shown here. Okay, now let's move to step 3. Second. Yep. Involve disabling this behavior using the command no auto summary in all routers. I turned off automatic summarization. I then cleared routing, as shown here, tables using clear IP route to force immediate route recollocations. Let's move to step 4. I verified that the routers now exchange full subnet information. R1 correctly displayed the 172, as shown here, 172.30.300.24 subnet, and the R3 learned the 172.30.100.24 subnet. This confirmed that that the Rep v2 was now operating in the full classless mode with subnet mask included. Let's move to step 5. Refining the routing configuration. I added a static default route on R2 IP route 0000.000.209.165.2012 to stimulate internet access. I then redistributed it using default information organized under router rep, allowing R1 and R3 to learn this default route, this default route dynamically, as shown here. Let's move to step number 6. Verifying. Verifying the router tables, R1 displayed an R entry for 0000, proving that it has learned the default route from R2 via rep. R2 showed the route as a static S entry. That's the main hole, and then I answered all the questions as A and B, yes and yes. Now let's move to the last part. Step 7. I verified complete connectivity. PCA and PCC were able to ping the stimulated internet host at 209.165.2012, and they were also able to ping each other successfully. This confirmed that the Rep v2 were fully functional. Automatic summarization was disabled, and the default route had been correctly propagated. That's all for part 2 and part 1. It's done all. Thank you so much for listening. I had my part 1 and my colleague had part 2, but I do it all. Thank you so much.